Hi, in this video we're going to talk about the inverse of these quadratic functions graphically, right? The properties of the inverse here. So the domain, the range, the graph, alright? So for quadratic function, we have to find the inverse of the function. I will be recommend that you doing by letting the I will using this method here. So y equals to fx by letting y equals to fx. For all the function that I do in the previous video is I letting y to be the inverse of fx. But only for quadratic function, when I want to find inverse, I will specify to using this because it will be easy for me to explain. So if you know that the x will be the inverse of y, right? If y is the image for this and you inverse the y here, you are getting the object, right? So this is also one of the method of finding the inverse. So by letting y equals to negative x minus 2 square plus 1 here, this is what I mean now. So letting y to be the fx, and you have to change the x become your subject, right? Become your subject. So I will moving the x minus 2 square, and we're moving this, we are getting 1 minus y, right? 1 minus y. This one negative will become, moving to that side, positive x minus 2 square. So this is why I choosing this method in finding the inverse for y, is because of this step here. So because quadratic without the restricted domain, the quadratic that without this domain is actually usually is negative infinity to infinity, right? It's not a one-to-one function, but we can find the inverse of quadratic if we restrict the domain. Means that we make the this function to be a one-to-one function. All right. So x minus 2 square. So you suppose here you have a positive negative here, which we don't write function in this way, right? So x minus 2 will be, there is a positive negative here, supposingly. But because of the given domain, since x was be greater than equals to, right? They have mentioned that x is greater than 2. If x is a number greater than 2, 3, 4, 5, or 6, you minus, you will surely get a positive number, right? So you will surely get a positive number here. So because this one to tell you that x minus 2 is something that at least 0 is a positive value here, right? Since this is greater than 2, of course it will be positive. So therefore you were choosing to be square root of 1 minus y, right? Square root of 1 minus y. So you have x will be square root of 1 minus y plus 2, right? And what is your x? Your x will be your f inverse here, right? Your x will be your inverse of y, which is square root of 1 minus y plus 2. And you replace the y here now back with x, right? This is the method that you are learning during your additional maths, right? So plus 2 here, right? F inverse, so 1 minus x plus 2. So in this video also, I'm going to tell you how if you're going to compare for this quadratic here, right? What if the same function, only for quadratic we have this type of case. So what if the domain is defined for x less than 2, right? Less than or equal to, then you have to do such that, okay, I will copy all this, this will be the same, all right? This 3 steps will be the same. It will be positive, negative 2 here. But after this step, it will be different. So since x less or equal to, means x is a something less than 2, right? If less than 2, this graph is also one-to-one function. You can sketch and see, right? So x minus 2, you will have, you know that you have x minus 2 equals to positive negative square root of 1 minus y, right? Up to this step. So because of the range given, you have to decide. This one is tell you that x less than 2. What is less than 2? 1, 0, negative 1. So if you put 0, you will get negative number. 1, you will get negative number. Any number less than 2, you will get negative number. So means that this is tell you that the x minus 2 is something less than 0, negative. So then you have to choose x minus 2 to be negative square root of 1 minus y. Can you see the difference? This is negative and this is positive. Why are you choosing positive? Why are you choosing negative? It's because of the range given here. So then you know that x will be negative square root of 1 minus y plus 2, right? And replace back here, you will have your inverse of x to be negative square root of, y here first, and 1 minus y plus 2. And later, you replace the y with x and negative square root of 1 minus x plus 2 here. Can you see that? The difference, one will be positive, one will be negative, right? It depends, the inverse of the quadratic is depend on the given domain, the restricted domain. Alright, so okay, in the same video, I'm going to talk more about this function here, that x more equal to. This is for you, it's a knowledge for you. If you have to take care about, you have to look at the domain. Okay, in this video, I'm going to talk about the graph for this and its inverse, and not about this. This one you can do it yourself. Alright, let's continue by looking at the graph of fx equals to negative x minus 2 squared here, right? So, okay, by using your ruler, you're sketching. Now you have to follow me to sketching when you study this video here. So xy, you make sure that the scala here will all 1 cm to 1, okay, 1 unit to 1. Alright, 2, negative 1, negative 2. This is what I mean here. 1, 2. Alright, 1, 2, 1 to 1. So that you can sketch, you can show that the relationship of the fx and its f inverse on the same axis here. So, as you know that the graph for x minus 2, right? Okay, I sketch separately, or in your mind, you know that this is a graph of quadratic which is already completing in the complete form, complete square form. So from there, you know that if there is a negative, or you can refer back to the quadratic function graph before you sketching this graph here. Alright, it's better to you have a very good skill in sketching the quadratic graph first. So negative, you know that if negative, there is a maximum point, right? And you open downwards, right? So what is the maximum point in this case here? The maximum point here. The maximum point will be 2, 1, right? 2, 1. So 1, 2, 2, 1. So this will be your maximum point. Supposingly, the graph will be something like this, right? The graph will be looking like this. Plus 2, 1. So the graph will be going down. But because of the defined restricted, this graph is not 1 to 1. It's not 1 to 1. It's not. The inverse does not exist. Suppose the inverse does not exist because you have positive, negative. But because of the restricted domain, what is mean by restricted domain? Means that I erase the curve here, such that the horizontal line is only intersect the curve at one point. That's why they said x must be greater or equal to, right? Greater or equal to. So now, this is a 1-to-1 function now. This is a 1-to-1 function now. So, then I'm going to transfer this one into the graph here, right? So you have 2, 1, right? 2, 1. So, okay, included 2, 1. So the graph will be, it's better for me to find the x intercept here. So for x intercept, the y have to be 0, right? The y have to be 0. So you have, for x intercept for this quadratic function, x intercept, the y have to be 0. So means that your negative x minus 2 square plus 1 have to be 0. Then you have x minus 2 square equals to 1, right? And x minus 2 to be plus minus 1, right? Plus minus 1. But this case, you have know that x is greater than 2, right? If x is greater than 2, we only consider since x is greater or equal to. So we only choose the positive one, right? X is greater, this one, x minus 2 is x minus 2 is greater or equal 0, right? More than 0. So this is something that more than 0. I'm choosing this. So I have 2 plus 1, you have 3, right? If you're doing this one, you have supposingly you have two value. One is 1 plus 2, one is negative 1 plus 2, which is 1. Supposed to be intercept here, there is another 1 here, right? There is another 1 here. But after you restricted the domain, you use hard gun, then they will only intercept at 3 here. So means there is an interception here, 3. So the graph will be looking like this way, right? Looking like this way. A complete one will be this one, right? A quadratic. But this is half of the graph here, right? This is a 1-to-1. So then at the same time, I'm going to sketch the graph of inverse of x, right? So very simple. So before that, I should tell you that you have to understand that the domain of f, and the domain of f will be the range of f inverse, and the range of f will be the domain of f inverse, the balik, right? So what is the domain for f here? You can read from the graph. The domain of f here is 2 to infinity. Domain of f will be 2 up to infinity here, right? From this one, 2 up to infinity. Can you see the graph, right? And the range for f, the range of f will be f, right? The range of f means the graph for f here, you have negative infinity up to 1, right? Negative infinity up to 1, close. Alright? So, if you already understand the concept of inverse function, the inverse functions and the graph of inverse function, and the function is always symmetry about the line y equals to x. Y equals to x means 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. If you sketch, there is a line here. So you have to show the relationship of the two graphs by drawing this line, y equals to x here. So, by refer to the video of how to sketch this square root function, you should know that the graph of this function will be, if you don't know, also never mind. Because why? You can take this graph and reflect on the line y equals to x here. For sure, they will be symmetrical about the line y equals to x here. So if you look at this point will be 2, 1 here, right? 2, 1. So when you reflected about the line y equals to x, the 2, 1 will become 1, 2 here. You have to remember, this will be 1, 2, right? And the x-intercept for this graph will be, the inverse will be the y-intercept here, the 3 here. So it will be reflected, right? So if you sketch the graph will be looking like this way. They will be symmetrical about the line y equals to x. So for sure, this will be your graph for y equals to inverse of x. And this will be the graph for y equals to fx here. Can you see that? The domain for fx, right, will be the range for fx. 2 to infinity. Here also 2 to infinity. And the range negative infinity to 1, right? The range for f will be the domain. You see the domain, negative infinity up to 1, right? So this is also negative infinity up to 1. The range here will become the domain for the f inverse here. So this is the properties of the inverse and its function graphically, alright? By using graph. So I hope you understand the properties here. And we may discuss further more example for this type of cases.